Picture this, a world where we can see the health of our planet in real time, from the vast oceans to the dense forests, all from hundreds of miles above Earth. What if I told you that the key to saving our planet might not be found on the ground, but in the stars? Space-based environmental monitoring is no longer science fiction. It's a reality that's reshaping how we understand and protect our world. From tracking carbon emissions to predicting natural disasters before they strike, satellites are becoming our eyes in the sky, offering insights that were once unimaginable. But this is just the beginning. Over the next few minutes, we'll dive into 25 groundbreaking predictions about how these technologies will revolutionize environmental monitoring, giving us the tools to tackle climate change, protect ecosystems, and secure a sustainable future. So, if you've ever wondered how we can truly safeguard our planet, stay with us, because the future of Earth's survival might just depend on what happens in space. Now, let's zoom in on one of the most transformative predictions in space-based environmental monitoring: real-time global carbon emission tracking. Imagine a network of advanced satellites orbiting Earth, constantly scanning the planet to measure carbon emissions with pinpoint accuracy. These satellites won't just capture snapshots, they'll provide a continuous stream of data, updating in real time. This means governments, organizations, and even local communities will have access to precise information about where emissions are coming from, how much is being released, and how these levels change over time. The implications of this technology are enormous. For the first time, we'll have a clear, global picture of carbon emissions, down to individual factories, power plants, and even transportation networks. This data will empower policymakers to make informed decisions, targeting the biggest sources of pollution with precision. It could also foster unprecedented levels of global cooperation as countries share data and work together to meet climate goals. Think about it: if every nation has access to the same real-time information, there's no room for ambiguity or excuses. Transparency will drive accountability, and accountability will drive action. But it doesn't stop there. Real-time carbon tracking could also revolutionize industries. Companies will be able to monitor their own emissions more effectively, identifying inefficiencies and reducing their carbon footprints. Investors and consumers will have access to this data too, pushing businesses to adopt greener practices. In essence, this technology could create a ripple effect, transforming how we approach sustainability on a global scale. So, what does this mean for the fight against climate change? It means we'll no longer be working in the dark. With real-time carbon emission tracking, we'll have the tools to measure progress, hold polluters accountable, and make smarter decisions for the planet. And as we'll see in the next prediction, this is just one piece of the puzzle when it comes to how space-based technologies are reshaping our future. Now, let's turn our attention to another groundbreaking prediction: hyper-accurate weather forecasting powered by space-based sensors. Picture this: a fleet of satellites equipped with cutting-edge technology, constantly monitoring Earth's atmosphere, oceans, and land surfaces. These sensors won't just observe weather patterns, they'll analyze them with incredible precision, providing forecasts that are far more detailed and reliable than anything we have today. The impact of this technology on natural disaster preparedness and response cannot be overstated. Take hurricanes, for example. With hyper-accurate forecasting, we'll be able to predict the exact path, intensity, and timing of a hurricane days or even weeks in advance. This means communities in the storm's path will have more time to evacuate, emergency services can prepare more effectively, and governments can allocate resources where they're needed most. The result: fewer lives lost, less property damage, and a faster recovery process. But hurricanes are just one piece of the puzzle. Droughts, which can devastate agriculture and water supplies, will also be better managed with this technology. Space-based sensors will monitor soil moisture levels, rainfall patterns, and even underground water reserves in real time. Farmers will receive early warnings about impending droughts, allowing them to adjust irrigation practices, plant drought-resistant crops, or seek alternative water sources. This could prevent crop failures, stabilize food prices, and protect livelihoods in vulnerable regions. The economic benefits of hyper-accurate weather forecasting are equally significant. Industries like shipping, aviation, and energy rely heavily on weather predictions to operate safely and efficiently. With more precise forecasts, airlines can optimize flight routes to avoid turbulence, shipping companies can plan safer voyages, and energy providers can better manage power grids during extreme weather events. These improvements will save billions of dollars annually, reducing the financial toll of weather-related disruptions. And let's not forget the human element. Imagine a world where weather forecasts are so reliable that people can plan their lives with confidence, knowing they'll be warned well in advance of any severe conditions. From weekend picnics to large-scale events, hyper-accurate forecasting will bring a new level of predictability to our daily lives. As we look ahead, it's clear that space-based weather monitoring will be a game-changer. By reducing the economic and human costs of natural disasters, this technology has the potential to save countless lives and transform how we interact with our environment. And as we'll see in the next prediction, the benefits of space-based environmental monitoring extend far beyond the weather. Now, shifting our focus from the skies to the seas, let's dive into the next transformative prediction: ocean health monitoring from space. Imagine satellites orbiting Earth, equipped with advanced sensors that can track ocean temperatures, acidity levels, and pollution in real time. These tools will give us an unprecedented understanding of the health of our oceans, which cover more than 70% of our planet and are vital to life as we know it. One of the most critical applications of this technology will be in protecting marine ecosystems. Rising ocean temperatures driven by climate change are already causing widespread damage, from coral bleaching to the displacement of marine species. With space-based monitoring, we'll be able to detect these changes as they happen, allowing scientists and policymakers to take swift action. For example, if a particular region of the ocean begins to warm rapidly, conservation efforts can be directed there to protect vulnerable species and habitats before it's too late. Acidity levels in the ocean, another major concern, will also be closely monitored. As the oceans absorb more carbon dioxide from the atmosphere, they become more acidic, threatening marine life, especially organisms with calcium carbonate shells like corals and shellfish. Satellites will provide real-time data on ocean acidity, helping researchers identify areas at risk and develop strategies to mitigate the impact. This could include creating marine protected areas or reducing pollution in vulnerable regions. Pollution is another area where space-based monitoring will make a huge difference. Satellites will detect oil spills, plastic waste, and other pollutants, often before they're visible from the ground. This early detection will enable faster cleanup efforts, minimizing harm to marine life and coastal communities. For instance, if a satellite identifies a large patch of plastic waste drifting toward a coral reef, cleanup teams can be dispatched immediately to prevent damage. The implications for fisheries are equally significant. Overfishing is a major threat to ocean health, depleting fish populations and disrupting ecosystems. With real-time data on fish populations and their habitats, governments and organizations can implement smarter fishing practices, such as setting quotas based on current population levels or closing fishing areas during critical breeding seasons. This will help ensure that fish stocks remain sustainable for future generations. Coral reefs, often called the rainforests of the sea, will also benefit from this technology. Satellites will monitor reef health, tracking factors like water temperature, acidity, and pollution that contribute to coral bleaching. Armed with this data, conservationists can take targeted actions such as reducing local pollution or transplanting heat-resistant corals to help reefs recover and thrive. The potential of space-based ocean monitoring is immense. By providing real-time global data on ocean health, this technology will empower us to protect marine ecosystems, combat overfishing, and address the root causes of coral reef degradation. It's a powerful reminder that the health of our oceans is deeply connected to the health of our planet, and that by taking care of the seas, we're taking care of ourselves. As we move forward, the next prediction will take us to another critical aspect of environmental monitoring: deforestation detection and prevention. Stay tuned to discover how space-based technologies will help us safeguard Earth's forests. Now, turning our attention from the oceans to the forests, let's explore how space-based technologies are set to revolutionize deforestation detection and prevention. Picture this: satellites orbiting high above Earth, equipped with cutting-edge sensors and cameras, scanning vast stretches of forest in real time. These systems will be able to spot illegal logging activities and deforestation hotspots as they happen, giving us the tools to intervene before irreversible damage is done. One of the most powerful aspects of this technology is its ability to monitor remote and hard-to-reach areas. Many of the world's most critical forests, like the Amazon and the Congo Basin, are located in regions where ground-based monitoring is challenging. Space-based systems will provide a bird's-eye view, capturing detailed images and data that reveal changes in forest cover, even in the most isolated locations. This means no illegal logging operation will be able to hide from the watchful eyes of these satellites. Artificial intelligence will play a crucial role in making this system effective. Analyzing satellite imagery manually would be time-consuming and prone to human error, but AI can process vast amounts of data quickly and accurately. Machine learning algorithms will be trained to recognize patterns associated with deforestation, such as the sudden appearance of logging roads or the clearing of large swaths of trees. When these patterns are detected, alerts can be sent to authorities in real time, enabling them to take immediate action. The impact of this technology on conservation efforts will be profound. For example, in regions where illegal logging is rampant, satellite data could lead to the identification and prosecution of those responsible. Governments and organizations could also use this information to implement stricter regulations and enforce protected areas more effectively. By stopping deforestation in its tracks, we can preserve biodiversity, protect indigenous communities, and maintain the vital role forests play in absorbing carbon dioxide from the atmosphere. Another exciting application is the ability to monitor reforestation efforts. Satellites can track the growth of newly planted trees, ensuring that reforestation projects are successful and sustainable. This data will be invaluable for organizations working to restore degraded lands and combat climate change. The integration of space-based monitoring and AI will also empower local communities. By providing real-time data on forest health, these tools can help indigenous groups and local authorities take proactive steps to protect their lands. For instance, if a satellite detects illegal activity in a community-managed forest, local leaders can quickly mobilize to address the threat. The potential of this technology to safeguard Earth's forests is immense. By combining the power of satellites with the precision of artificial intelligence, we can detect deforestation as it happens, intervene swiftly, and protect these vital ecosystems for future generations. It's a reminder that the fight to save our forests is not just about conservation, it's about ensuring the health of our planet and all who depend on it. As we continue our journey through these predictions, the next one will take us to the world of agriculture, where space-based technologies are set to transform how we grow our food. Stay tuned to discover how satellites will revolutionize precision farming and address global food security challenges. Now, shifting our focus from forests to fields, let's explore how space-based technologies are poised to revolutionize agriculture. Imagine satellites orbiting Earth, not just observing forests or oceans, but also providing farmers with incredibly detailed insights into their crops, soil, and water resources. This is the future of precision agriculture, where data from space will transform how we grow food, making farming more efficient, sustainable, and productive. Satellites equipped with advanced sensors will monitor soil health in ways that were once unimaginable. They'll measure moisture levels, nutrient content, and even detect early signs of soil degradation. This information will allow farmers to make precise decisions about fertilization, irrigation, and crop rotation, ensuring that every patch of land is used to its fullest potential. No more guesswork, just data-driven strategies that maximize yield while minimizing waste. Crop growth will also be tracked with unprecedented accuracy. Satellites will capture high-resolution images of fields, revealing how crops are developing over time. Farmers will be able to identify areas where plants are struggling due to pests, disease, or poor soil conditions. With this real-time data, they can take targeted action to address these issues before they spread, saving entire harvests from potential disaster. Water usage, one of the most critical factors in agriculture, will also be optimized through space-based monitoring. Satellites will measure how much water crops are using and how efficiently it's being distributed. This will help farmers avoid over-irrigation, which not only wastes water but can also harm soil quality. In regions facing water scarcity, this technology could be a game-changer, ensuring that every drop is used wisely to sustain crops and communities. The impact of precision agriculture on global food security cannot be overstated. With the world's population expected to reach nearly 10 billion by 2050, the demand for food will only increase. Space-based technologies will help farmers produce more food on the same amount of land, reducing the need to clear forests for agriculture. This is especially important in developing countries where small-scale farmers often lack access to advanced tools and resources. By providing them with satellite data, we can empower these farmers to grow more food, reduce hunger, and improve livelihoods. For example, in regions prone to drought, satellites can help farmers identify the best crops to plant based on soil and climate conditions. In areas with unpredictable weather, real-time data can guide decisions about when to plant and harvest, reducing the risk of crop failure. And in places where pests are a constant threat, early detection through satellite imagery can prevent widespread damage, ensuring that food reaches markets and tables. The integration of space-based data with ground-based technologies like drones and smart irrigation systems will further enhance precision agriculture. Farmers will have a complete picture of their fields, from the health of individual plants to the overall condition of their soil. This holistic approach will not only boost productivity, but also promote sustainable farming practices, reducing the environmental impact of agriculture. As we look to the future, it's clear that space-based technologies will play a vital role in feeding the world. By providing farmers with the tools they need to grow food more efficiently and sustainably, we can address the challenges of food security, protect natural resources, and ensure that everyone has access to nutritious food. Next, we'll turn our attention to the polar regions, where satellites are set to provide critical insights into the melting ice caps and their impact on our planet. Stay tuned to discover how space-based monitoring is helping us understand one of the most pressing issues of our time. Now, let's journey from the fields to the frozen frontiers of our planet, where space-based technologies are shedding light on one of the most urgent environmental challenges of our time, the melting polar ice caps. As Earth's climate continues to warm, the polar regions are experiencing dramatic changes, and satellites are playing a crucial role in monitoring these shifts with incredible precision. Satellites equipped with advanced sensors are now able to measure the thickness and extent of polar ice in ways that were once impossible. By capturing high-resolution images and using radar technology, these space-based systems can track even the smallest changes in ice cover over time. This data is essential for understanding how quickly the ice is melting and what it means for the planet. One of the most significant impacts of melting polar ice is sea level rise. As ice sheets in Antarctica and Greenland melt, they contribute vast amounts of water to the oceans, threatening coastal communities worldwide. Satellites provide scientists with the tools to measure this process in real time, offering critical insights into how sea levels are changing and what we can expect in the coming decades. But the implications go beyond rising seas. Polar ice plays a vital role in regulating Earth's climate. The bright, reflective surface of ice helps to bounce sunlight back into space, keeping the planet cool. As ice melts, it's replaced by darker ocean water, which absorbs more heat and accelerates global warming. This feedback loop, known as the albedo effect, is a key factor in climate change, and satellites are helping us understand its full impact. Space-based monitoring also allows scientists to study the behavior of glaciers and ice shelves in unprecedented detail. For example, satellites can detect when large chunks of ice break off from glaciers, a process known as calving. These events can have significant consequences as they contribute to sea level rise and can destabilize entire ice sheets. By tracking these changes, scientists can better predict how polar ice will respond to future warming. The data collected by satellites is not just valuable for researchers, it's also essential for policymakers and communities. Accurate predictions about sea level rise and its impacts are crucial for planning and adaptation. Coastal cities, for instance, need to know how much their shorelines will change in the coming years to build resilient infrastructure and protect vulnerable populations. Moreover, space-based monitoring is helping us understand the broader ecological impacts of melting polar ice. For example, as Arctic sea ice disappears, it affects the habitats of polar bears, seals, and other wildlife. Changes in ice cover also influence ocean currents and weather patterns, with potential consequences for ecosystems and human activities around the globe. As we look to the future, the role of space-based technologies in monitoring polar ice will only grow. With more advanced satellites and improved data analysis techniques, we'll gain even deeper insights into these critical regions. This knowledge will be vital for addressing the challenges of climate change, protecting vulnerable communities, and preserving the delicate balance of our planet's ecosystems. Next, we'll explore how satellites are helping cities tackle another pressing issue: urban heat islands. Stay with us to learn how space-based monitoring is shaping the future of urban planning and climate resilience. Now, let's shift our focus from the icy poles to the bustling heart of our cities, where another critical environmental challenge is unfolding: urban heat islands. As urban areas continue to expand, the concentration of buildings, roads, and other infrastructure creates pockets of intense heat that can significantly impact both human health and energy use. Satellites are stepping in to provide a bird's-eye view of this phenomenon, offering data that could transform how cities adapt to rising temperatures. Urban heat islands occur when cities experience higher temperatures than surrounding rural areas due to human activities and the materials used in construction. Dark surfaces like asphalt and concrete absorb and retain heat, while the lack of vegetation reduces natural cooling. This effect can make cities several degrees hotter than nearby regions, especially during heat waves. Satellites equipped with thermal imaging sensors are now able to map these temperature differences with remarkable precision, identifying the hottest areas and tracking changes over time. This data is invaluable for city planners and policymakers. By understanding where heat islands are most severe, cities can implement targeted strategies to mitigate their effects. For example, increasing green spaces such as parks and rooftop gardens can help cool urban areas by providing shade and releasing moisture into the air. Reflective materials for roads and buildings can also reduce heat absorption, lowering temperatures and making cities more comfortable for residents. Beyond comfort, addressing urban heat islands is crucial for public health. Extreme heat can lead to heat-related illnesses, particularly for vulnerable populations like the elderly and those with pre-existing conditions. By using satellite data to identify high-risk areas, cities can develop early warning systems and cooling centers to protect residents during heat waves. This proactive approach could save lives and reduce the strain on healthcare systems. Energy consumption is another area where satellite monitoring can make a difference. As temperatures rise, so does the demand for air conditioning, leading to higher energy use and increased greenhouse gas emissions. By pinpointing the hottest parts of a city, planners can prioritize energy-efficient building designs and renewable energy solutions, reducing both costs and environmental impact. Satellite data also opens the door to greener urban planning. For instance, cities can use this information to design more sustainable transportation networks, reducing the heat generated by vehicles and improving air quality. Integrating satellite insights with smart city technologies could create urban environments that are not only cooler but also more resilient to climate change. Looking ahead, the role of space-based monitoring in tackling urban heat islands will only grow. As satellite technology advances, we'll gain even more detailed and real-time data, enabling cities to respond more effectively to rising temperatures. This knowledge will be essential for creating livable, sustainable urban spaces in a warming world. Next, we'll turn our attention to another pressing issue: how satellites are revolutionizing early warning systems for wildfires. Stay tuned to discover how space-based technologies are helping us predict and respond to these devastating events. Now, let's move from the heat of our cities to the flames that threaten our forests and communities. Wildfires have become an increasingly urgent global challenge, fueled by climate change, drought, and human activity. But here's where space-based technologies are stepping in to make a life-saving difference. Satellites equipped with advanced sensors are now capable of detecting wildfires in their earliest stages, giving us a critical head start in combating these devastating events. Imagine a wildfire just beginning to spark in a remote forest. In the past, it might have gone unnoticed for hours, even days, until it grew large enough to be seen from the ground or by aircraft. But today, satellites orbiting high above Earth can spot the faintest signs of a fire almost instantly. These sensors detect heat anomalies and smoke plumes, sending real-time data to firefighting teams on the ground. This early detection is a game changer, allowing responders to act before the fire spreads out of control. But it doesn't stop there. Artificial intelligence is taking this capability to the next level. By analyzing vast amounts of satellite data, AI algorithms can predict where wildfires are most likely to start based on factors like weather patterns, vegetation dryness, and historical fire activity. This predictive modeling helps authorities allocate resources more effectively, positioning firefighting teams and equipment in high-risk areas before a fire even begins. It's like having a crystal ball for wildfire prevention. The integration of AI and satellite technology also enhances our ability to monitor fires as they spread. Satellites can track the movement of a wildfire in real time, providing detailed maps that show its direction, speed, and intensity. This information is invaluable for evacuation planning, helping communities get out of harm's way before it's too late. It also allows firefighters to strategize their response, targeting the most critical areas to contain the blaze and minimize damage. The impact of these early warning systems goes beyond saving lives and property. Wildfires release massive amounts of carbon dioxide and other pollutants into the atmosphere, contributing to climate change. By detecting and extinguishing fires sooner, we can reduce these emissions and protect our planet's delicate balance. Additionally, preserving forests helps maintain biodiversity and safeguards the habitats of countless species. As satellite technology continues to advance, so too will our ability to predict and prevent wildfires. Future systems may even incorporate drones and ground-based sensors, creating a comprehensive network that leaves no fire undetected. This collaborative approach could revolutionize how we manage wildfires, turning reactive responses into proactive solutions. With these tools at our disposal, we're not just fighting fires, we're preventing them, and that's a future worth striving for. Next, we'll explore how satellites are transforming our understanding of air quality, offering real-time insights that could improve public health on a global scale. Stay tuned to learn how space-based monitoring is helping us breathe easier. Now, let's shift our focus from the flames of wildfires to the invisible threats in the air we breathe. Air quality is a silent yet critical issue affecting millions of people worldwide, and space-based technologies are poised to revolutionize how we monitor and address this challenge. Satellites equipped with advanced sensors are now capable of providing continuous, real-time data on air quality across the globe, offering unprecedented insights into pollution levels and their sources. Picture this, a bustling city where millions of people go about their daily lives, unaware of the invisible pollutants swirling around them. In the past, air quality monitoring relied heavily on ground-based sensors, which provided limited coverage and often missed pollution hotspots. But with satellites orbiting Earth, we can now track air quality on a global scale, identifying everything from industrial emissions to vehicle exhaust in real time. These satellites measure key pollutants like nitrogen dioxide, carbon monoxide, and particulate matter, painting a comprehensive picture of air quality that was once impossible to achieve. This real-time data is a game-changer for public health. By pinpointing pollution sources, governments and organizations can take targeted actions to reduce emissions and protect vulnerable populations. For example, if a satellite detects unusually high levels of nitrogen dioxide over a specific industrial area, authorities can investigate and enforce stricter regulations to curb emissions. Similarly, urban planners can use this data to design cleaner, more sustainable cities, prioritizing green spaces and low-emission transportation options. The impact of space-based air quality monitoring extends beyond immediate policy changes. Over time, this data can reveal long-term trends, helping scientists and policymakers understand how pollution levels are changing and what factors are driving those changes. This information is invaluable for crafting evidence-based strategies to combat air pollution, from implementing cleaner energy solutions to promoting public awareness campaigns. One of the most exciting possibilities is the integration of satellite data with mobile apps and public platforms. Imagine receiving real-time air quality updates on your phone, allowing you to plan your day around cleaner air. This level of accessibility empowers individuals to make informed decisions about their health, whether it's choosing a less polluted route for a morning jog or staying indoors during a high-pollution day. As satellite technology continues to advance, so too will our ability to monitor and improve air quality. Future systems may even incorporate predictive modeling, using historical data and weather patterns to forecast pollution levels days in advance. This proactive approach could transform how we manage air quality, shifting from reactive measures to long-term solutions that benefit everyone. With satellites watching over us, we're not just tracking pollution, we're taking meaningful steps toward cleaner air and healthier lives. Next, we'll dive into how space-based technologies are helping us monitor the health of our oceans, offering critical insights into one of Earth's most vital ecosystems. Stay tuned to discover how satellites are safeguarding the blue heart of our planet. Now, let's turn our attention from the air we breathe to the frozen giants that hold the key to Earth's freshwater reserves. Glaciers, often referred to as the planet's natural water towers, are retreating at an alarming rate due to rising global temperatures. space-based technologies are stepping in to monitor this critical phenomenon with unparalleled precision, offering insights that could shape the future of water resource management and climate adaptation. Imagine standing at the edge of a massive glacier, watching as it slowly melts into rivers that supply water to millions of people downstream. For centuries, these icy reservoirs have been a lifeline for communities, agriculture, and ecosystems. But as glaciers shrink, the consequences ripple far beyond their icy surfaces. Satellites equipped with high-resolution imaging and radar systems are now tracking these changes in real time, measuring the thickness, movement, and retreat of glaciers across the globe. This data is not just a snapshot of the present, it's a window into the future of water availability. One of the most significant contributions of space-based monitoring is its ability to provide consistent long-term data. Unlike ground-based observations, which can be limited by accessibility and harsh conditions, satellites offer a continuous view of even the most remote glaciers. This information is crucial for climate scientists, who use it to refine models predicting sea level rise and global warming impacts. For instance, by analyzing how quickly glaciers in the Himalayas or the Andes are retreating, researchers can better understand how these changes will affect river systems and water supplies in regions that depend on them. The implications of glacial retreat extend far beyond science. For communities in mountainous regions, glaciers are a primary source of freshwater, especially during dry seasons. As these ice masses shrink, the timing and volume of meltwater can become unpredictable, threatening agriculture, hydropower, and even drinking water supplies. Space-based monitoring provides early warnings of these shifts, enabling governments and organizations to plan for water scarcity and develop sustainable management strategies. For example, in regions like Central Asia, where millions rely on glacial meltwater, satellite data can inform decisions about reservoir construction, irrigation systems, and conservation efforts. But the story doesn't end there. The retreat of glaciers also has global implications, particularly for sea level rise. As glaciers melt, they contribute to rising ocean levels, which can displace coastal communities and alter ecosystems. By tracking these changes from space, scientists can provide policymakers with the data needed to prepare for and mitigate these impacts. This includes everything from building resilient infrastructure to relocating vulnerable populations. Looking ahead, the integration of satellite data with advanced modeling tools could revolutionize how we respond to glacial retreat. Predictive systems could forecast water availability years in advance, helping communities adapt to changing conditions. Additionally, this data could support international efforts to address climate change, highlighting the urgent need to reduce greenhouse gas emissions and protect these vital natural resources. With satellites keeping a watchful eye on Earth's glaciers, we're not just observing their retreat, we're gaining the tools to adapt and respond. Next, we'll explore how space-based technologies are tackling another pressing environmental challenge, the growing problem of space debris and its impact on our planet. Stay tuned to learn how we're safeguarding both Earth and the space around it. Now, let's shift our gaze from Earth's icy landscapes to the vast expanse above, where a different kind of environmental challenge is unfolding. Space debris, often referred to as space junk, is becoming an increasingly pressing issue as our reliance on satellites grows. From defunct satellites to discarded rocket stages, this debris orbits Earth at incredible speeds, posing risks not only to active spacecraft but also to our planet's environment. Space-based technologies are stepping up to monitor this growing problem, offering solutions that could safeguard both our orbital infrastructure and Earth itself. Imagine a scenario where a piece of space debris, no larger than a pebble, collides with a satellite at thousands of miles per hour. The impact could create a cascade of smaller fragments, each capable of causing further damage, a phenomenon known as the Kessler syndrome. This chain reaction could render entire orbits unusable, disrupting communication, navigation, and even weather forecasting systems that rely on satellites. But the risks don't stop there. When space debris re-enters Earth's atmosphere, it can pose environmental and safety hazards, releasing harmful materials or even causing damage if it reaches the ground. Satellites equipped with advanced sensors and tracking systems are now playing a crucial role in monitoring this debris. By mapping the location, trajectory, and size of space junk, these systems provide early warnings to satellite operators, helping them avoid collisions. But the benefits extend beyond protecting spacecraft. By tracking debris as it re-enters the atmosphere, scientists can predict where and when it will land, minimizing risks to populated areas and ecosystems. This data is also vital for understanding how space debris interacts with Earth's atmosphere, including the potential release of pollutants or hazardous materials. One of the most significant challenges in managing space debris is its sheer volume. With thousands of objects orbiting Earth, international cooperation is essential to address this issue effectively. Organizations like the United Nations and the European Space Agency are already working on guidelines for debris mitigation, but the problem requires a global effort. Satellites can provide the data needed to enforce these guidelines, such as identifying which countries or companies are responsible for creating debris and ensuring they take steps to clean it up. This collaborative approach could pave the way for sustainable space exploration, ensuring that future generations can continue to benefit from satellite technology without the looming threat of space junk. Looking ahead, the integration of satellite data with artificial intelligence could revolutionize how we manage space debris. Predictive systems could forecast potential collisions years in advance, allowing operators to move satellites out of harm's way. Additionally, this data could support the development of technologies for debris removal, such as robotic arms or nets designed to capture and deorbit junk. By combining monitoring with active cleanup efforts, we can create a safer and more sustainable environment both in space and on Earth. As we continue to explore the cosmos, the need to protect our orbital environment becomes increasingly clear. Space-based monitoring is not just about safeguarding satellites, it's about preserving the delicate balance between Earth and the space around it. Next, we'll dive into another critical aspect of environmental monitoring: how satellites are helping us track and manage coastal erosion in the face of rising sea levels. Stay tuned to discover how technology is shaping the future of our shorelines. Now, let's turn our attention to the ever-changing edges of our planet, the coastlines. Coastal erosion is a growing concern as rising sea levels and extreme weather events threaten communities, ecosystems, and infrastructure. Space-based technologies are stepping in to provide real-time monitoring of these vulnerable areas, offering a lifeline for those who depend on them. By tracking changes in coastlines with unprecedented precision, satellites are helping us understand and adapt to the challenges posed by a warming planet. Imagine a coastal town where homes, businesses, and critical infrastructure are at risk of being swallowed by the sea. Without accurate data, planning for the future becomes a guessing game. Satellites equipped with high-resolution cameras and advanced sensors can capture detailed images of coastlines, revealing even the smallest shifts in land and water. This real-time data allows scientists and policymakers to identify erosion hotspots, predict future changes, and develop strategies to protect vulnerable areas. One of the most powerful tools in this effort is predictive modeling. By combining satellite data with advanced algorithms, researchers can simulate how coastlines will evolve under different scenarios, such as rising sea levels or increased storm activity. These models provide invaluable insights for coastal planning, helping communities decide where to build seawalls, restore natural barriers like mangroves, or even relocate infrastructure away from high-risk zones. For example, in areas where erosion is accelerating, predictive models can guide decisions about when and where to invest in protective measures, ensuring resources are used effectively. But the benefits of space-based coastal monitoring extend beyond infrastructure. Coastal ecosystems such as wetlands and coral reefs are also at risk from erosion and rising seas. Satellites can track changes in these habitats, providing data that supports conservation efforts. For instance, by monitoring the health of mangrove forests, which act as natural buffers against storm surges, scientists can identify areas in need of restoration. This not only protects biodiversity but also enhances the resilience of coastal communities. The role of international collaboration cannot be overstated. Coastal erosion is a global issue, and sharing satellite data across borders ensures that all nations have access to the tools they need to adapt. Organizations like the United Nations and the European Space Agency are already working to make this data widely available, fostering cooperation and innovation in coastal management. By pooling resources and expertise, we can develop solutions that benefit everyone, from small fishing villages to bustling port cities. Looking ahead, the integration of satellite data with artificial intelligence promises to take coastal monitoring to the next level. Predictive systems could forecast erosion trends decades in advance, giving communities more time to prepare. Additionally, this data could support the development of adaptive infrastructure, such as floating buildings or dynamic seawalls that adjust to changing conditions. By combining real-time monitoring with long-term planning, we can create coastlines that are not only resilient but also sustainable. As we continue to face the challenges of a changing climate, the importance of space-based coastal monitoring becomes increasingly clear. It's not just about protecting land. It's about safeguarding the livelihoods, ecosystems, and cultures that depend on our coastlines. Next, we'll explore how satellites are revolutionizing global water resource management, ensuring that every drop counts in a world where water is becoming increasingly scarce. Stay tuned to learn how technology is shaping the future of this vital resource. Now, shifting our focus from the edges of our planet to its lifeblood, let's dive into how space-based technologies are transforming the way we manage one of Earth's most precious resources, water. Fresh water is essential for life, yet it's becoming increasingly scarce in many parts of the world. Satellites are stepping up to the challenge, offering a bird's-eye view of rivers, lakes, and aquifers to ensure sustainable water use and address the growing crisis of water scarcity. Picture this: a sprawling river basin that supplies water to millions of people, but its levels are dropping year after year. Without accurate data, managing this resource becomes a game of guesswork. Satellites equipped with advanced sensors can measure water levels, track flow rates, and even detect changes in groundwater reserves. This real-time monitoring provides a comprehensive picture of freshwater resources, enabling governments and organizations to make informed decisions about water allocation and conservation. One of the most critical applications of this technology is in arid regions, where water scarcity is a daily reality. In places like the Middle East or parts of Africa, satellites can identify underground aquifers and monitor their depletion rates. This data is invaluable for planning sustainable water extraction, ensuring that these vital reserves are not overused. For example, in areas where agriculture depends heavily on groundwater, satellite data can help farmers optimize irrigation practices, reducing waste and preserving water for future generations. But the benefits don't stop there. Satellites can also track the health of rivers and lakes, detecting pollution or changes in water quality. This is particularly important for communities that rely on these water bodies for drinking water, fishing, or irrigation. By identifying contamination early, authorities can take swift action to protect public health and ecosystems. In regions prone to droughts, satellite data can provide early warnings, giving communities time to prepare and implement water-saving measures. The integration of satellite data with artificial intelligence is taking water resource management to new heights. predictive models can forecast water availability under different climate scenarios, helping policymakers plan for the future. For instance, in areas where rainfall patterns are becoming unpredictable, these models can guide decisions about building reservoirs, improving water storage, or even relocating populations to areas with more reliable water sources. This forward-thinking approach ensures that communities are better equipped to handle the challenges of a changing climate. International collaboration plays a key role in this effort. Water knows no borders, and sharing satellite data across nations fosters cooperation in managing shared resources. Organizations like the World Bank and the United Nations are already leveraging satellite technology to support water management projects in developing countries. By pooling resources and expertise, we can create solutions that benefit everyone, from small rural villages to sprawling urban centers. Looking ahead, the potential for space-based water monitoring is immense. Imagine a world where every drop of water is accounted for, where communities have the tools they need to thrive even in the face of scarcity. Satellites are not just helping us manage water, they're helping us secure a sustainable future for generations to come. Next, we'll explore how these same technologies are being used to track methane leaks from space, another critical piece of the puzzle in our fight against climate change. Stay tuned to learn how satellites are uncovering hidden threats to our planet's atmosphere. Now, let's turn our attention to an invisible yet powerful threat to our planet's climate: methane. While carbon dioxide often takes the spotlight in climate discussions, methane is a far more potent greenhouse gas, capable of trapping heat in the atmosphere at a much higher rate. The good news: satellites are stepping in to tackle this challenge by detecting methane leaks from space, offering a game-changing tool in the fight against climate change. Imagine a vast oil field stretching as far as the eye can see. Beneath the surface, methane, a byproduct of oil and gas extraction, can escape unnoticed into the atmosphere. These leaks, whether from pipelines, storage facilities, or drilling sites, contribute significantly to global warming. But with satellites equipped with advanced sensors, we can now pinpoint these leaks with incredible precision. These space-based tools can detect methane concentrations in the atmosphere, even identifying small leaks that would otherwise go undetected. One of the most promising applications of this technology is in the oil and gas industry. Companies can use satellite data to locate and repair leaks quickly, reducing emissions and saving valuable resources. For example, in regions like the Permian Basin in the United States, satellite monitoring has already uncovered significant methane leaks, prompting operators to take corrective action. This not only helps the environment but also improves operational efficiency, as methane is the primary component of natural gas, a valuable energy resource. But methane leaks aren't limited to industrial operations. Landfills, for instance, are another major source of methane emissions. As organic waste decomposes, it releases methane into the air. Satellites can monitor these sites, providing data that helps waste management companies implement strategies to capture methane and convert it into energy. In cities like Mumbai and Lagos, where landfills are massive and densely populated, this technology could play a crucial role in reducing emissions and improving air quality. Natural sources of methane, such as wetlands and permafrost, are also under the watchful eye of satellites. As global temperatures rise, these natural reservoirs of methane are at risk of releasing even more of this potent gas into the atmosphere. By tracking these changes, scientists can better understand the feedback loops driving climate change and develop strategies to mitigate their impact. For instance, in the Arctic, where permafrost thaw is accelerating, satellite data is helping researchers predict and prepare for potential methane releases. The implications for energy policies are profound. Governments and regulatory bodies can use satellite data to enforce stricter emission standards and hold industries accountable. In the European Union, for example, satellite-based methane monitoring is being integrated into climate policies, ensuring that member states meet their emissions reduction targets. Similarly, in countries like Canada and Australia, this technology is shaping discussions around sustainable energy practices and the transition to cleaner fuels. What makes this even more exciting is the potential for global collaboration. Methane knows no borders, and its impact on the climate is felt worldwide. By sharing satellite data across nations, we can create a unified approach to tackling methane emissions. Organizations like the United Nations and the International Energy Agency are already leveraging this technology to support global climate initiatives, fostering cooperation between developed and developing countries. Looking ahead, the ability to track methane leaks from space represents a significant leap forward in our efforts to combat climate change. It's not just about identifying the problem, it's about empowering governments, industries, and communities to take action. With satellites as our eyes in the sky, we can turn the tide on methane emissions and move closer to a sustainable future. Next, we'll explore how space-based technologies are helping us monitor biodiversity from orbit, shedding light on the health of ecosystems and the species that depend on them. Stay tuned to discover how satellites are becoming guardians of life on Earth. Now, let's shift our focus to the incredible diversity of life on Earth and how satellites are becoming essential tools in protecting it. Biodiversity, the variety of plant and animal species that make up our ecosystems, is under threat like never before. Habitat loss, climate change, and human activity are pushing many species to the brink of extinction. But space-based technologies are stepping in to monitor these changes from orbit, offering a powerful way to track and protect the delicate balance of life on our planet. Imagine a vast rainforest teeming with life. From towering trees to tiny insects, every species plays a role in maintaining the health of the ecosystem. But when habitats are destroyed or altered, entire species can disappear, disrupting the balance. Satellites equipped with high-resolution cameras and advanced sensors can now monitor these changes in real time. They can track deforestation, map the spread of invasive species, and even observe the migration patterns of animals across continents. This data is invaluable for conservationists working to protect endangered species and restore damaged ecosystems. One of the most exciting applications of this technology is in tracking species migration. Many animals, from birds to whales, travel vast distances each year in search of food, breeding grounds, or better climates. Satellites can follow these journeys, providing insights into how climate change and human activity are affecting migration routes. For example, in the Arctic, where melting ice is altering the habitats of polar bears and seals, satellite data is helping scientists predict how these species will adapt or struggle in the coming decades. But it's not just about individual species. Satellites are also helping us understand the health of entire ecosystems. By monitoring changes in vegetation, water sources, and land use, scientists can identify areas at risk of collapse. In the Amazon rainforest, for instance, satellite imagery has revealed alarming rates of deforestation, prompting governments and organizations to take action. Similarly, in Africa's savannas, satellites are tracking the impact of droughts on wildlife populations, helping conservationists allocate resources more effectively. The implications for conservation efforts are profound. With satellite data, we can identify critical habitats that need protection, monitor the effectiveness of conservation programs, and even predict future threats. In places like Madagascar, where unique species are found nowhere else on Earth, this technology is helping to safeguard biodiversity hotspots. By combining satellite data with on-the-ground efforts, we can create a more comprehensive approach to conservation, ensuring that ecosystems remain resilient in the face of growing challenges. Another key benefit of space-based biodiversity monitoring is its ability to support global cooperation. biodiversity loss is a worldwide issue and no single country can tackle it alone. Satellites provide a shared resource, enabling nations to collaborate on conservation initiatives. Organizations like the United Nations and the World Wildlife Fund are already using satellite data to support international efforts to protect endangered species and restore ecosystems. This global perspective is essential for addressing the interconnected challenges of biodiversity loss and climate change. Looking ahead, the potential for space-based biodiversity monitoring is immense. As technology advances, satellites will become even more precise, allowing us to track changes at a finer scale. This could revolutionize how we approach conservation, enabling us to detect threats earlier and respond more effectively. From protecting coral reefs to preserving ancient forests, satellites are becoming guardians of life on Earth, helping us ensure that future generations can enjoy the rich diversity of our planet. Next, we'll dive into how satellites are providing early warnings for volcanic activity, helping to protect communities and air travel from the devastating impacts of eruptions. Stay tuned to discover how space-based technologies are keeping us one step ahead of nature's most powerful forces. Now, let's turn our attention to one of nature's most awe-inspiring yet dangerous phenomena: volcanic eruptions. These powerful events can reshape landscapes, disrupt air travel, and pose serious risks to nearby communities. But thanks to advancements in space-based technologies, we're now better equipped than ever to monitor volcanic activity in real time, providing critical early warnings that can save lives and minimize damage. Satellites equipped with thermal imaging capabilities are at the forefront of this effort. By detecting heat signatures from space, these advanced systems can identify changes in a volcano's temperature long before an eruption occurs. This thermal data is crucial because it often signals the movement of magma beneath the surface, giving scientists a heads-up that an eruption might be imminent. For example, in places like Iceland and Indonesia, where volcanic activity is frequent, satellite data has already been used to predict eruptions days or even weeks in advance. But it's not just about heat. Satellites also monitor gas emissions such as sulfur dioxide, which can spike dramatically before an eruption. By tracking these changes from orbit, scientists can piece together a clearer picture of a volcano's behavior. This information is then combined with data from ground-based sensors, which measure seismic activity, ground deformation, and other indicators. Together, these tools create a comprehensive monitoring system that provides a more accurate and timely warning of potential eruptions. The benefits of this technology are immense, especially for communities living near active volcanoes. Early warnings allow authorities to evacuate residents, secure infrastructure, and prepare emergency response teams. In 2018, for instance, satellite data played a key role in predicting the eruption of Mount Agong in Bali, enabling the safe evacuation of tens of thousands of people. Similarly, in the Philippines, satellite monitoring helped mitigate the impact of the Taal volcano eruption in 2020, reducing the risk to both lives and livelihoods. Air travel is another area where real-time volcanic monitoring is making a difference. Volcanic ash clouds can pose a serious hazard to aircraft, damaging engines and reducing visibility. By tracking eruptions as they happen, satellites provide airlines with up-to-date information on ash cloud movements, allowing them to reroute flights and avoid dangerous areas. This not only protects passengers and crew, but also minimizes disruptions to global air travel. Looking ahead, the integration of satellite data with artificial intelligence promises to take volcanic monitoring to the next level. Machine learning algorithms can analyze vast amounts of data from multiple sources, identifying patterns and predicting eruptions with even greater accuracy. This could revolutionize how we respond to volcanic threats, enabling faster and more precise decision-making. As we continue to refine these technologies, the potential to protect lives and infrastructure from volcanic hazards will only grow. From remote island communities to bustling cities, space-based monitoring is becoming an indispensable tool in our efforts to coexist with the planet's most powerful forces. Next, we'll explore how satellites are shedding light on another pressing environmental issue, light pollution, and its impact on ecosystems and human health. Stay tuned to learn how space-based technologies are helping us reclaim the night sky. Now, let's shift our gaze from the fiery power of volcanoes to a quieter but equally significant issue, light pollution. While it might not seem as dramatic as an erupting volcano, the excessive artificial light that fills our night skies has far-reaching consequences for both ecosystems and human health. Space-based technologies are stepping in to help us better understand and address this growing problem. Satellites equipped with specialized sensors are now able to map light pollution on a global scale, capturing detailed images of how artificial light spreads across cities, towns, and even rural areas. These images reveal not just the brightness of our nights, but also the patterns of light usage, helping scientists identify areas where energy is being wasted. For instance, poorly designed streetlights or overlit commercial areas can be pinpointed, providing valuable data for cities looking to reduce their energy consumption. But the impact of light pollution goes beyond wasted electricity. For wildlife, artificial light disrupts natural behaviors that depend on darkness. Nocturnal animals such as bats and owls rely on the cover of night to hunt and navigate. Excessive light can confuse their internal clocks, leading to disorientation and even population declines. Similarly, sea turtles, which use moonlight to guide their hatchlings to the ocean, often become disoriented by bright coastal lights, putting their survival at risk. Humans are not immune to the effects of light pollution either. Exposure to artificial light at night can interfere with our circadian rhythms, the internal processes that regulate sleep and wakefulness. This disruption has been linked to a range of health issues, from sleep disorders to increased risks of chronic conditions like obesity and depression. By monitoring light pollution from space, we can better understand its impact on human health and develop strategies to mitigate these effects. One of the most exciting possibilities of space-based light pollution monitoring is its potential to help us reclaim the night sky. Dark skies are not just a matter of beauty, they are a vital part of our natural heritage. By identifying areas where light pollution is most severe, cities and communities can implement targeted measures to reduce unnecessary lighting. This could include using energy-efficient bulbs, installing motion sensors, or adopting lighting designs that direct light downward rather than into the sky. The benefits of these efforts extend beyond preserving the stars. Reducing light pollution can lead to significant energy savings, cutting down on greenhouse gas emissions and lowering electricity costs. It also creates opportunities for ecotourism, as areas with dark skies become destinations for stargazers and nature enthusiasts. As space-based technologies continue to advance, their role in tracking and combating light pollution will only grow. By shining a light, or rather, by helping us dim the light, satellites are giving us the tools to protect both our planet and ourselves. Next, we'll explore how these same technologies are being used to monitor another critical environmental issue, soil degradation. Stay tuned to learn how space-based systems are helping us safeguard the very ground beneath our feet. Now, let's turn our attention to the ground beneath our feet, soil. While it might not always be top of mind, soil health is absolutely critical to our survival. From growing the food we eat to supporting entire ecosystems, healthy soil is the foundation of life on Earth. But soil degradation is a growing problem, threatening agricultural productivity and contributing to desertification in many parts of the world. Fortunately, space-based technologies are stepping in to help us monitor and protect this vital resource. Satellites equipped with advanced sensors are now capable of tracking soil health on a global scale. These sensors can measure moisture levels, nutrient content, and even the presence of harmful chemicals in the soil. By analyzing this data, scientists can identify areas where soil is degrading and pinpoint the causes, whether it's over-farming, deforestation, or climate change. This information is invaluable for farmers, policymakers, and conservationists working to combat desertification and restore degraded land. One of the most exciting applications of this technology is its ability to support sustainable farming practices. For example, satellites can provide farmers with detailed maps of their fields, showing exactly where soil quality is declining. Armed with this information, farmers can adjust their practices, such as rotating crops, reducing tillage, or applying targeted fertilizers. These changes not only improve soil health but also boost crop yields, making agriculture more efficient and sustainable. In regions prone to desertification, space-based soil monitoring can be a game changer. By tracking changes in soil moisture and vegetation cover, satellites can provide early warnings of land degradation. This allows communities to take action before the land becomes barren, such as planting drought-resistant crops or implementing water-saving irrigation techniques. In some cases, satellite data has even been used to guide large-scale reforestation projects, helping to restore degraded land and prevent further desertification. The benefits of space-based soil monitoring extend beyond agriculture. Healthy soil plays a crucial role in combating climate change by storing carbon and reducing greenhouse gas emissions. By identifying areas where soil is losing its ability to store carbon, satellites can help us target conservation efforts and maximize their impact. This is especially important in regions like the Amazon rainforest, where deforestation and soil degradation are releasing vast amounts of carbon into the atmosphere. As space-based technologies continue to evolve, their role in monitoring and protecting soil health will only grow. By giving us a clearer picture of what's happening beneath the surface, these tools are helping us safeguard the foundation of life on Earth. Next, we'll dive into another pressing environmental issue, the growing problem of plastic pollution in our oceans and rivers. Stay tuned to learn how satellites are helping us tackle this global challenge. Now, shifting our focus to the waters that cover our planet, let's explore how space-based technologies are tackling one of the most visible and urgent environmental crises, plastic pollution. Every year, millions of tons of plastic waste end up in our oceans and rivers, harming marine life, disrupting ecosystems, and even entering the food chain. The challenge has always been tracking this pollution in real time, but thanks to advancements in satellite technology, we're now able to monitor plastic waste like never before. Satellites equipped with high-resolution cameras and advanced sensors can detect plastic debris floating on the surface of oceans and rivers. These systems are capable of identifying even small concentrations of plastic, providing a comprehensive view of pollution hotspots around the globe. By analyzing this data, scientists and environmental organizations can pinpoint areas where cleanup efforts are most needed, ensuring resources are used effectively. One of the most groundbreaking aspects of this technology is the integration of artificial intelligence. AI algorithms can process vast amounts of satellite imagery, distinguishing plastic waste from natural materials like seaweed or driftwood. This not only speeds up the detection process but also improves accuracy, allowing for more targeted interventions. For example, AI can identify patterns in how plastic accumulates, helping predict where new hotspots might form based on ocean currents and weather conditions. The impact of real-time plastic tracking extends beyond cleanup efforts. Governments and policymakers can use this data to enforce stricter regulations on plastic production and disposal. By identifying the sources of plastic pollution, such as rivers that carry waste from urban areas into the ocean, authorities can implement measures to reduce plastic leakage at its origin. This could include improving waste management systems, promoting recycling initiatives, or even banning single-use plastics in high-risk areas. In addition to aiding policy-making, satellite data is empowering local communities and organizations to take action. For instance, cleanup crews can use real-time maps of plastic pollution to plan their operations more efficiently, focusing on areas with the highest concentrations of waste. This not only maximizes their impact but also reduces the time and cost associated with large-scale cleanup efforts. Looking ahead, the potential for space-based plastic monitoring is immense. As satellite technology continues to improve, we'll be able to track smaller particles of plastic, including microplastics, which pose a significant threat to marine life and human health. This could lead to even more precise cleanup strategies and a deeper understanding of how plastic pollution spreads across the globe. By combining the power of satellites with artificial intelligence, we're not just tracking plastic pollution, we're taking meaningful steps towards solving it. Next, we'll turn our gaze upward to explore how space-based systems are monitoring solar radiation and its impact on our climate. Stay tuned to discover how this technology is helping us better understand the forces shaping our planet's future. Now, let's turn our attention to the skies above and explore how space-based technologies are revolutionizing our understanding of solar radiation and its profound impact on Earth's climate. Solar radiation, the energy emitted by the sun, plays a critical role in shaping our planet's weather patterns, temperature, and overall climate. While we've long known that the sun drives Earth's climate system, accurately measuring and tracking solar radiation has been a challenge until now. Satellites equipped with advanced sensors are now capable of monitoring solar radiation with unprecedented precision. These instruments measure the amount of energy reaching Earth's atmosphere, as well as how it interacts with clouds, aerosols, and other atmospheric components. By collecting this data, scientists can better understand how solar radiation influences global temperatures, weather systems, and even long-term climate trends. One of the most significant benefits of this technology is its ability to improve climate models. Current models rely on estimates of solar radiation, which can lead to uncertainties in predicting future climate scenarios. With real-time, accurate data from satellites, researchers can refine these models, making them more reliable and precise. This is especially important for understanding the complex interplay between natural solar cycles and human-induced climate change. For example, satellites can help distinguish between fluctuations in solar activity and the effects of greenhouse gas emissions, providing a clearer picture of how each factor contributes to global warming. Beyond improving predictions, solar radiation monitoring has practical implications for renewable energy. Solar power generation depends heavily on the amount of sunlight reaching Earth's surface. By tracking solar radiation patterns, satellites can help optimize the placement and efficiency of solar farms, ensuring they operate at peak performance. This data can also assist in predicting energy output, making solar power a more reliable and consistent energy source. Another critical application is in understanding extreme weather events. Solar radiation influences atmospheric circulation, which in turn affects phenomena like hurricanes, droughts, and heat waves. By monitoring changes in solar energy, scientists can better predict these events, giving communities more time to prepare and mitigate their impact. For instance, early warnings of prolonged heat waves could help cities implement cooling strategies, reducing the risk of heat-related illnesses and deaths. Looking ahead, the implications of solar radiation monitoring are vast. As satellite technology continues to advance, we'll gain even deeper insights into how the sun shapes our climate. This could lead to breakthroughs in our understanding of long-term climate trends, such as ice ages or periods of warming, and how they might unfold in the future. By combining this knowledge with other environmental data, we can develop more effective strategies to address climate change and protect our planet. With satellites keeping a watchful eye on the sun, we're not just observing our climate, we're unlocking the secrets of its past, present, and future. Next, we'll delve into how space-based systems are tracking changes in atmospheric composition, shedding light on another crucial piece of the climate puzzle. Stay tuned to discover how this technology is helping us breathe easier and plan smarter for the challenges ahead. Now, let's shift our focus to the invisible yet vital layer surrounding our planet, the atmosphere. Space-based technologies are set to revolutionize how we track changes in atmospheric composition, giving us a clearer understanding of the gases and particles that shape our climate and health. From ozone to aerosols, these elements play a critical role in everything from global warming to air quality, and satellites are now giving us the tools to monitor them like never before. One of the key areas of focus is ozone, a molecule that exists in two layers of the atmosphere. In the stratosphere, ozone acts as a shield, protecting life on Earth from harmful ultraviolet radiation. However, at ground level, ozone becomes a pollutant, contributing to smog and respiratory issues. Satellites equipped with advanced sensors can now monitor ozone levels across the globe, tracking both its protective and harmful effects. This data is invaluable for understanding how human activities, such as industrial emissions, impact ozone concentrations and for developing policies to protect public health and the environment. Aerosols, tiny particles suspended in the air, are another critical component of atmospheric composition. These particles come from natural sources like volcanic eruptions and wildfires, as well as human activities such as burning fossil fuels and industrial processes. Aerosols have a complex relationship with climate. They can reflect sunlight back into space, cooling the planet, or absorb heat, contributing to warming. Satellites are now capable of measuring the distribution and properties of aerosols, helping scientists understand their role in climate change and weather patterns. For example, this data can improve predictions of monsoon seasons or the spread of wildfire smoke, which has direct implications for agriculture and public health. Beyond climate, monitoring atmospheric composition has significant implications for air quality. Poor air quality is a leading cause of health problems worldwide, contributing to respiratory diseases, heart conditions, and even premature deaths. Satellites can provide real-time data on pollutants like nitrogen dioxide, sulfur dioxide, and particulate matter, helping cities identify pollution hotspots and implement targeted solutions. For instance, this technology could guide urban planners in designing greener cities or help governments enforce stricter emission standards for industries and vehicles. The potential for improving air quality standards is immense. With precise global data from satellites, policymakers can make informed decisions to reduce pollution and protect vulnerable populations. This technology also empowers citizens by providing accessible information about air quality in their area, encouraging communities to take action and hold leaders accountable. Looking ahead, the ability to track changes in atmospheric composition will only grow more sophisticated. As satellite technology advances, we'll gain even deeper insights into how gases and particles interact with each other and with Earth's climate system. This knowledge will be crucial for addressing global challenges like climate change, improving public health, and ensuring a cleaner, safer environment for future generations. With satellites keeping a close watch on our atmosphere, we're not just observing the air we breathe, we're unlocking the tools to protect it. Next, we'll explore how space-based systems are monitoring the thawing of permafrost, a process with far-reaching consequences for our planet. Stay tuned to learn how this technology is helping us tackle one of the most pressing issues in the fight against climate change. Now, let's turn our attention to the frozen landscapes of the Arctic, where a hidden but critical process is unfolding: permafrost thaw. Permafrost, the permanently frozen ground that covers vast areas of the Northern Hemisphere, is beginning to melt at an alarming rate due to rising global temperatures. This thawing process isn't just a local issue, it has global implications, particularly when it comes to the release of greenhouse gases like methane and carbon dioxide. Space-based technologies are stepping in to monitor this phenomenon with unprecedented precision, offering insights that could shape how we address one of the most urgent challenges in the fight against climate change. Satellites equipped with advanced sensors are now capable of tracking changes in permafrost conditions across the Arctic. By measuring surface temperatures, ground deformation, and even the release of gases, these tools provide a comprehensive picture of how quickly permafrost is thawing and where the most significant changes are occurring. This data is crucial for understanding the scale of the problem and predicting its impact on global climate systems. For instance, as permafrost thaws, it releases methane, a greenhouse gas that is far more potent than carbon dioxide in the short term. Satellites can detect these methane emissions, helping scientists quantify their contribution to global warming and refine climate models. The implications of permafrost thaw extend beyond climate science. In the Arctic, entire ecosystems and communities are built on frozen ground. As the permafrost melts, it destabilizes the land, leading to infrastructure damage, such as collapsing roads and buildings. Satellites can monitor these changes in real time, providing early warnings to communities and governments. This information is invaluable for planning and adapting to the challenges posed by thawing permafrost, from relocating vulnerable settlements to reinforcing critical infrastructure. Moreover, the data gathered by satellites can influence Arctic policies on a broader scale. For example, understanding the rate and extent of permafrost thaw can inform international agreements on greenhouse gas reductions and climate adaptation strategies. It can also guide investments in sustainable development in the Arctic, ensuring that economic activities like mining or tourism are conducted in ways that minimize environmental harm. By providing a clear, evidence-based picture of what's happening on the ground, space-based monitoring empowers policymakers to make informed decisions that balance economic growth with environmental protection. Looking ahead, the role of satellites in monitoring permafrost thaw will only become more critical. As technology advances, we'll gain even more detailed insights into the processes driving permafrost melt and its global consequences. This knowledge will be essential for developing effective mitigation strategies, from capturing methane emissions to restoring Arctic ecosystems. By keeping a close watch on these frozen landscapes, satellites are helping us tackle one of the most complex and far-reaching challenges of our time. As we continue to explore the future of space-based environmental monitoring, our next focus will be on how satellites are revolutionizing the way we predict and respond to floods and droughts. Stay tuned to learn how this technology is helping communities around the world prepare for extreme weather events and build resilience in the face of a changing climate. Now, shifting our focus to another critical application of space-based environmental monitoring, let's explore how satellites are transforming our ability to predict and respond to floods and droughts. These extreme weather events, which are becoming more frequent and severe due to climate change, pose significant risks to communities, agriculture, and infrastructure worldwide. Space-based systems are stepping up to provide real-time data that can save lives, protect property, and help societies adapt to these growing challenges. Satellites equipped with advanced imaging and sensing technologies are now capable of monitoring water levels in rivers, lakes, and reservoirs with remarkable precision. By tracking changes in water bodies over time, these systems can detect early signs of potential flooding or drought conditions. For example, when a river begins to swell beyond its normal levels, satellites can capture this data and relay it to ground-based systems, which then analyze the information to issue timely warnings. This integration of satellite data with ground-based sensors creates a powerful early warning system, giving communities precious time to prepare and respond. In the case of floods, this real-time monitoring can mean the difference between life and death. satellites can identify areas at risk of flooding days or even weeks in advance, allowing authorities to evacuate residents, reinforce levees, and deploy emergency resources. For instance, during the monsoon season in South Asia, where devastating floods are common, satellite data has already been used to improve flood forecasting and reduce the impact on vulnerable populations. Similarly, in drought-prone regions, satellites can monitor soil moisture levels and vegetation health, providing early indicators of water scarcity. This information is invaluable for farmers who can adjust irrigation practices or switch to drought-resistant crops to mitigate losses. The integration of satellite data with ground-based sensors also enhances the accuracy of flood and drought predictions. Ground sensors provide localized, high-resolution data, while satellites offer a broader, global perspective. Together, these tools create a comprehensive picture of water-related risks, enabling more precise modeling and forecasting. For example, in regions like the American Midwest, where both floods and droughts can occur within the same year, this combined approach helps policymakers and emergency responders make informed decisions about water management and disaster preparedness. Beyond immediate disaster response, the data gathered by these systems has long-term benefits for water resource management. By analyzing trends in flood and drought patterns over time, scientists can identify areas that are becoming more vulnerable to these events due to climate change. This knowledge can guide infrastructure investments, such as building flood barriers or expanding water storage capacity, to build resilience in at-risk regions. It can also inform policies aimed at sustainable water use, ensuring that communities have access to this vital resource even in the face of changing climate conditions. Looking ahead, the role of space-based systems in monitoring floods and droughts will only grow more critical. As climate change intensifies, the need for accurate, real-time data to predict and respond to extreme weather events will become even more urgent. Advances in satellite technology, such as higher-resolution imaging and faster data transmission, will further enhance our ability to monitor these events and protect vulnerable communities. By combining the power of space-based systems with ground-based sensors, we're not just reacting to disasters, we're staying one step ahead, building a safer and more resilient future. As we continue to explore the future of space-based environmental monitoring, our next focus will be on how satellites are tracking changes in cloud cover and their impact on weather patterns and climate. Stay tuned to learn how this technology is helping us better understand the complex interactions between clouds, weather, and climate change. Now, turning our attention to the skies above, let's delve into how satellites are revolutionizing our understanding of cloud cover and its profound influence on weather and climate. Clouds play a critical role in regulating Earth's temperature, reflecting sunlight back into space and trapping heat within the atmosphere. Yet, their complex behavior has long posed challenges for scientists trying to predict weather patterns and understand climate change. Space-based monitoring is now unlocking new insights into these dynamic systems, offering a clearer picture of how clouds shape our planet's future. Satellites equipped with advanced imaging and spectral analysis tools are capable of tracking cloud formations with unprecedented detail. By observing cloud types, thickness, and movement across the globe, these systems provide data that enhances the accuracy of weather forecasts. For instance, high-resolution satellite imagery can detect the formation of storm clouds hours before they develop into severe weather events, giving meteorologists crucial lead time to issue warnings. This capability is particularly valuable in regions prone to sudden thunderstorms or hurricanes, where early detection can save lives and reduce economic losses. Beyond short-term weather forecasting, satellite data is also shedding light on the long-term role of clouds in climate change. Clouds act as both a cooling and warming force depending on their altitude, density, and composition. Low, thick clouds tend to reflect sunlight, cooling the Earth's surface, while high, thin clouds trap heat, contributing to warming. satellites are now able to measure these effects on a global scale, helping scientists refine climate models and better predict how cloud cover will respond to rising temperatures. For example, data from space-based systems has revealed that certain regions are experiencing shifts in cloud patterns, such as fewer low-level clouds in subtropical areas, which could accelerate warming in those zones. The implications of this research extend far beyond the scientific community. Improved understanding of cloud dynamics can inform strategies for mitigating and adapting to climate change. For instance, if satellites detect a trend toward more frequent and intense cloud cover in a particular region, policymakers might prioritize infrastructure upgrades to handle increased rainfall or flooding. Similarly, insights into how clouds influence solar radiation could guide the development of renewable energy projects, such as optimizing the placement of solar farms in areas with minimal cloud interference. One of the most exciting advancements in this field is the integration of satellite data with artificial intelligence. Machine learning algorithms can analyze vast amounts of cloud data to identify patterns and predict future changes with remarkable accuracy. This combination of space-based monitoring and artificial intelligence is transforming our ability to forecast not just weather, but also long-term climate trends. For example, researchers are using these tools to study how cloud cover might change in response to global warming, providing critical information for climate adaptation strategies. As we look to the future, the role of satellites in tracking cloud cover will only become more vital. With climate change altering weather patterns and increasing the frequency of extreme events, understanding the behavior of clouds is essential for building resilience. Advances in satellite technology, such as higher resolution sensors and faster data processing, will further enhance our ability to monitor these complex systems. By combining space-based observations with ground-based research, we're gaining a deeper understanding of how clouds influence our planet and how we can better prepare for the challenges ahead. With this deeper understanding of cloud dynamics, our next exploration takes us to the final frontier of space-based environmental monitoring, tracking space weather and its impact on Earth. Stay tuned to discover how satellites are helping us safeguard our planet from the unpredictable forces of the cosmos. Now, shifting our gaze beyond Earth's atmosphere, let's explore how satellites are stepping into the realm of space weather monitoring. Space weather, driven by the sun's activity, includes phenomena like solar flares, geomagnetic storms, and coronal mass ejections. These events, while occurring millions of miles away, have profound effects on our planet, influencing everything from satellite operations to power grids and even daily communication systems. Space-based monitoring is becoming essential to predict and mitigate these impacts, ensuring the safety and reliability of our increasingly interconnected world. Satellites equipped with specialized sensors are now capable of observing the sun's activity in real time, providing early warnings of solar storms. For instance, when a massive solar flare erupts, it releases bursts of radiation and charged particles that can travel toward Earth. Satellites positioned between the sun and our planet detect these emissions, giving scientists critical data to forecast potential disruptions. This early warning system is invaluable, as solar storms can interfere with satellite communications, disrupt GPS signals, and even damage sensitive electronics onboard spacecraft. One of the most significant risks posed by space weather is its impact on power grids. Intense geomagnetic storms triggered by solar activity can induce electric currents in power lines, potentially causing widespread blackouts. In one notable example, a geomagnetic storm in 1989 left millions in Quebec without power for hours. Today, satellites are helping to prevent such scenarios by monitoring solar activity and providing data that allows grid operators to take protective measures, such as temporarily reducing power loads or isolating vulnerable sections of the grid. Beyond infrastructure, space weather also affects Earth's environment. solar storms can alter the composition of the upper atmosphere, impacting satellite orbits and even influencing climate patterns over time. Satellites tracking these changes provide insights into how space weather interacts with our atmosphere, helping scientists refine models of atmospheric behavior. This knowledge is crucial for improving the accuracy of long-term climate predictions and understanding the broader implications of solar activity on our planet. The importance of protecting satellites themselves cannot be overstated. These vital tools are often the first line of defense against space weather, but they are also vulnerable to its effects. High-energy particles from solar flares can damage satellite components, shorten their lifespans, or even render them inoperable. To address this, engineers are designing satellites with enhanced shielding and redundancy systems, while space weather monitoring provides the data needed to position satellites in safer orbits or shut down sensitive instruments during solar events. Looking ahead, the integration of space weather data with artificial intelligence promises to revolutionize our ability to predict and respond to solar activity. Machine learning algorithms can analyze vast datasets from satellites, identifying patterns that might precede major solar storms. This predictive capability could provide even earlier warnings, giving governments, industries, and individuals more time to prepare for potential disruptions. For example, airlines could reroute flights to avoid radiation exposure, and satellite operators could adjust their systems to minimize damage. As our reliance on technology grows, so does the need to safeguard it from the unpredictable forces of space weather. Satellites are not just tools for monitoring these phenomena, they are also critical assets that must be protected. By advancing our understanding of space weather and developing robust monitoring systems, we can ensure the resilience of our infrastructure, protect our environment, and maintain the seamless flow of communication and data that underpins modern life. With this final frontier of space-based environmental monitoring, we're not just observing the cosmos, we're learning how to coexist with it. As we bring our journey through these 25 predictions to a close, it's clear that space-based environmental monitoring is poised to revolutionize how we understand and protect our planet. From tracking carbon emissions in real time to predicting natural disasters with unprecedented accuracy, these advancements are not just about technology, they're about safeguarding the future of life on Earth. Each prediction we've explored highlights a critical area where satellites and space-based systems are making a tangible difference, whether it's protecting our oceans, preserving biodiversity, or mitigating the impacts of climate change. What ties all these predictions together is their potential to empower us with knowledge. By providing real-time data and actionable insights, space-based monitoring enables governments, organizations, and individuals to make informed decisions that benefit both people and the planet. Imagine a world where we can predict wildfires before they start, monitor deforestation as it happens, or track the health of our oceans from orbit. These aren't just possibilities, they're the future we're building today. But this future depends on all of us. Staying informed about these advancements and supporting the technologies and policies that drive them is crucial. Whether it's advocating for sustainable practices, supporting space research, or simply sharing what you've learned today, every action counts. Together, we can ensure that these predictions become realities, creating a healthier, more resilient planet for generations to come. So, what's next? Stay curious, stay engaged, and keep exploring the incredible ways space-based environmental monitoring is shaping our world. If you found this video insightful, don't forget to like, subscribe, and hit the notification bell to stay updated on the latest in futuristic technologies and environmental innovations. The future is out there, let's make it a bright